This is R.d.sharma solution class 12 chapter 19. Exercise is 19.20. We are taking indefinite integrals. Now in this question what we will do, because the power is higher, so we will divide, and if there is any other possibility just guide me. So first thing we'll do is we will divide these two, numerator denominator. So x square minus x plus 1, and here x cube plus x square plus 2x plus 1. Now what do you want? You want x cube. So you need to multiply this with x. You will get, we'll just do the similar terms now. So x cube, negative x into x will be negative x square. Just write it here. X into 1 will be x, and there is no constant term. Now we'll subtract these two. So x cube minus x cube is, this will get cancelled. X square minus x square will be 2x square. 2x minus x will be x and plus 1. So we need one more thing. We will multiply this by 2. So it will be 2x square, negative 2x and plus 2. This is plus 2. I've written 3. I'll just change it. Now let us subtract these two. This gets cancelled. This x minus 2x will be 3x, and 1 minus 2. I told you it was 2. 1 minus 2 will be negative 1. So this will be negative 1. So how do we write this? I already told you in the question we did in the beginning. So first will be x plus 2. Then we will have 3x minus 1. And then quotient, divisor and remainder. So 3x minus 1 divided by x square minus x plus 1. So we'll integrate this. X plus 2 integration is very easy. But 3x minus 1 by x square minus x plus 1. So this will do. Let us call this 3x minus 1 and represent it in the differentiation form of x square minus x plus 1. So a into x square minus x plus 1, and then we have a constant b. So what this will be, differentiation of this will be 2x minus 1 and plus b. Now multiply this 2ax, and this will be b and minus a, and this is equal to 3x minus 1. So we'll try to equate these similar terms. That is 3x will be equal to 2ax and b minus a will be equal to negative 1. What do you get from here? A will be equal to 3 by 2 and b will be equal to, b minus 3 by 2 is equal to negative 1. So 1, this goes here. 3 by 2 minus 1 will be half. So b will be equal to half. Now a and b we have, just call it as I2. This whole is I. And how to write this now? This equation. So this I1 will be, a was what? 3 by 2. And this equation I'm talking about. So 3 by 2 is here. We'll take it outside. So 2x minus 1 divided by x square minus x plus 1 will remain like this in the denominator. X square minus x plus 1. Then we have this half. And there is nothing in the numerator. It will be simply x square minus x plus 1. So this will be, call it as I2. Call this as I3. So I2 will be what? Just take t equals to x square minus x plus 1. dt will be what? We already done it. It's 2x minus 1. So dt will be equal to 2x minus 1 into dx. So the numerator becomes a dt. So this is dt and this is t in the denominator. So log modulus of t plus constant of integration. Let us call it as c1. dt by t is log t. T can be replaced by x square minus x plus 1 here. So x square minus x plus 1 plus constant of integration. This 3 by 2 is here. Now coming to I3, we have to make it as a perfect square. So what is the coefficient of x, which is 1? Just divide by 1 by 2, square it, add it and subtract it. So add and subtract half square. Half square minus half square. So a square plus b square minus 2ab is x minus half whole square. So I'm integrating now dx divided by, since half was there, so I'm including half also in front of integration. X minus half whole square, what is remaining? See, this already we have taken. So 1 minus 1 by 4 will be 4 minus 1 by 4, that is 3 by 4, and that has to be written in the square form. So root 3 by 2 whole square you can write. So this will be plus root 3 by 2 whole square. Now you already know 1 by x square plus a square integration is 1 by a tan inverse x by a. So 1 by 2 is already there. 1 by a is root 3 by 2 tan inverse x by a. So x minus half divided by root 3 by 2. So this 2 goes up. It will be cancelled by 2. So only this root 3 will remain. This is tan inverse. X minus half can be written as 2x minus 1 by 2. Root 3 by 2 is already in the denominator. 2 gets cancelled. So this is 2x minus 1 divided by root 3. Now this integration is also remaining. The integration is very simple. X square by 2 plus 2x plus constant of integration. So let me write constant of integration C2 here. Let us call the constant of integration C3 here. So x square plus 2x, you already know how to do this. So calling it as C3. Now let's do the final thing. First term has to be written as x squared plus 2 plus 2x. C1, C2, C3, I'll combine them and call them as a capital C. The second term will be this one, 3 by 2 and log modulus of x squared minus x plus 1. And then the final term, 1 by root 3 tan inverse 2x minus 1 by root 3. This will be in the bracket, not in the modulus. So plus constant of integration C1, C2, C3 became C. So you can call it as a simple one constant. This is your final result. So this is how we need to do this. Okay, same to same thing I have guided you, and you can try it by yourself. This is a good question. This is an important question as per my justification. Next is this one. So x square into x raised 4 plus 4 divided by x square plus 4. So we'll do one thing. We'll just multiply these numerator. That is both term we are going to multiply. X square plus 4 will be in the it needs to be in the denominator. So we are dividing this. So x raised 6 plus 4x square is the multiplication of the numerator. We need x raised 6. So x raised 4 will be multiplied. X raised 6 will be there. There is no x raised 4, so just write 4x raised 4. Now when we subtract these two, x raised 6 and x raised 6 gets cancelled. This 4x square will remain like this, and this 4x raised 4 will become negative 4x raised 4. So let me write it as a negative 4x to the power 4. And since we need the highest power, because in the division it's always there, so we'll just swap this term. It will not affect anything. Negative 4x raised 4 and then plus 4x square. Okay, now we need x raised 4 and negative 4. So multiply this with negative 4 and x square. Negative 4x square into x square will be negative 4x raised 4. So negative 4x raised 4. 4 into 4 is 16. Negative 16x square. Now just subtract these two. These terms will get cancelled. 4 minus 16 will be 20. So 20x square. We need still to be getting some numbers. So let's just multiply by 20. You will get 20x square. And there is one more term which is getting added, which is 80. Now subtract these two. This gets cancelled. 20x square gets cancelled. Only negative 80 will remain. So how are we going to write this? So first term will be x to the power 4 minus 4x to the power square plus 20. And then we have, since it is negative 80 will come in front. So let me make this as negative here itself. Negative. So negative 80 divided by x square plus 4. Now see, x square plus 4 can be written as x square plus 2 square. Direct integration of x raised 4 and all these terms will be very easy. So let's do this first. So I'm doing this x raised 5 divided by 5. You already know that the integration of x raised to the power n is x raised n plus 1 divided by n plus 1 plus constant of integration. That's what I'm doing right here. X to the power 5 by 5 minus 4. This will be x cubed by 3 and plus 20x. Okay. Now coming to this one, I can write directly because I know the integration. So we are integrating all of these. Negative t, and this is 1 by x square plus a square integration. So dx by x square plus a square. This is 1 by a tan inverse x by a. 1 by 2 tan inverse x by 2 this will be. So let me write it here. Negative 80 is already there. So multiply it by 1 by 2 and tan inverse x by 2. And what I was saying, you will get a constant term from here. You will get a constant term from here also. So just call it as C. We are adding C1, C2 and calling it as C. So that's your final answer. Just write a 40 here. So x raised 5 by 5 minus 4x cubed by 3 plus 20x minus 40 tan inverse x by 2 plus constant of integration. That's your final result. Now if you know the division, everything will be easier for you. Okay, that's your result. Alright. You can do this by yourself. It's quite easy. Only the division is the key here. Integration is very easy. Okay, now you can adopt the same strategy here. You can divide these two, or you can follow my scheme. I see cx. This 6x I will add and subtract. 6x and subtract. 12, add 12 and subtract 12. So what you are going to get, x square plus 6x plus 12 is already there in the denominator. So x square plus 6x plus 12 I have connected. These three terms I have already collected, and negative 6x. So negative just take outside. 6x plus 12 you can write. And denominator will be x square plus 6x plus 12. So x square plus 6x plus 12 here. Here also x square plus 6x plus 12. Now these two terms gets cancelled. 1 minus 6x plus 12 divided by x square plus 6x plus 12. Now integration of this one. This integration is quite easier. It is just x. We'll use it later. Negative, don't forget about this negative. 6x plus 12 by x square plus 6x plus 12. Now can you make the factor of x square plus 6x plus 12? I don't know. I hope not. So we'll apply the same technique which we are used to. We'll represent 6x plus 12 in the form of differential or differentiation of x square plus 6x plus 12. So 6x plus 12 can be written as a into d by dx of x square plus 6x plus 12 plus a constant term which is b. 6x plus 12 will be equal to a into, this will be 2x plus 6 plus this b. Now this equation is very important, which we are going to use in a short while. So 6x plus 12 will be equal to, just multiply these terms, so it will be 2ax plus 6a plus b. So let me change it. Now equate these two. 6x will be equal to 2ax and this will be 6a plus b will be equal to 12. This gives you a equals to 3. When you put this a equals to 3, 6 is 18, 18 goes on the right, you will get a negative 6. So b will be negative 6 here. Now please remember this equation number 1. 6x plus 12 will replace this a into 2x plus 6 plus b, but the denominator remains same. So I'm using this equation and writing it directly. Call it as I1. Now this whole is I. I'm calling this as I1. So this will be a. A is 3. I'm taking it outside. 2x plus 6 is already there. X square plus 6x plus 12 in the denominator is already there. Then we have this negative 6. So make it negative here itself. 6 outside, integration. And what is in the denominator? X square plus 6x plus 12. You already know how to do this. So x square plus 6x plus 12 I'm writing. First term is, call it as I2 and I3. So I2 will be equal to what? See, if you take x square equals to x square plus 6x plus 12, dt by dt will be equal to directly 2x plus 6 into dx. We have already done that differentiation. So 2x plus 6 into dx, this numerator will be dt. So this will be dt and 3 is already outside. We have a t in the denominator plus constant of integration. So log modulus of t plus constant of integration, 3 was already outside. So 3 log modulus of t was x square plus 6x plus 12. Write it like this. X square plus 6x plus 12 plus constant of integration. Call it as c1. And there will be one more constant coming from x also. Call it as c3. Now we are left with one more term which we have called as I3. So let us make it as a perfect square. The coefficient of x is 6. 6 divided by 2 is 3. Square the 3 which is 9. Add 9, subtract 9. So a square plus b square plus 2ab, x plus 3 whole square. So this will be x plus 3 whole square. And what is remaining? 12 minus 9 is 3. 3, but you have to write it in the perfect square. So you just write root 3 whole square. So what do we get? 6 integration of dx divided by x plus 3 whole square plus root 3 whole square, that I just told you how we did it. So this will be 6, 1 by a root 3, tan inverse x by a, tan inverse x plus 3 by root 3 plus constant of integration, of course. Call it as, say, c2. Now let's resolve the 6 by root 3. Let's do it here. 6 by root 3, multiply numerator denominator by root 3. 6 root 3 divided by 3, 3 to the 6, so 2 root 3 it will be. So this whole will be 2 root 3. I'll replace 2 root 3 in place of 6 by root 3. So we have x here. Let's write x here. Since there is a negative sign, remember negative sign? So we'll change both the signs of I1 and this I2 and I3. So x is already there. What is negative here? So this will be negative 3 log modulus of x square plus 6x plus 12. And what about this one? This is already negative, remember? So we have a negative, so it will make it as a positive. So just make positive 2 root 3. I replace this by 6 by root 3 in place of this thing I've written here, tan inverse x plus 3 by root 3. Now c1, c2, c3, all the constants can be collected and can be called as a capital C. This is your final result. Okay, this is what you can get as a reference. You can solve it by yourself. So 19.20 we have already done. If you want to like it, otherwise it's just free education. Enjoy.